Okay. You'll need your calculators for this lesson, definitely. So if you have your calculator, take it out now, because you'll need it for all the questions. And we'll start off with degree, so if you can put your calculator in degree mode. So what we're having a look at is trigonometric equations. So let me give you a simple example to start with. Let's imagine we have an equation like this. Sine x minus a half equals 0. And you want to solve it. Well, you might think, okay, that's not too bad. I just have to say sine x equals a half. And then if I use my calculator, I can get x equals sine inverse a half, which is equal to 30. So what I want you to do on your calculator is type in sine 30 minus a half. Type that in, please. Yeah, but at least pretend you're typing it in. Like, oh, yeah, 0. Can you type it in? Thank you. That was more convincing. Now, what I want you to type in now, I want you to type this in now in the calculator. Sine 150 minus a half equals, well, it'll equal 0. And then I want you to type in this, please. Sine 390 minus a half. 0. That will also equal 0. So the point I'm trying to make here is there's more than one answer. In fact, maybe some people can see here there are infinite answers. So there are two things we need to have a look at. The first thing is I should tell you like a range for the x. So now there's not infinite answers. But there's still more than one answer. Does anybody actually know how many answers? Two answers. So we're going to learn how do we find all of the answers. Okay? Now just before we do that, in the next lesson we'll have a look at the graphs for sine and cos and tan. So the sine graph goes like this. So part of the reason we have two answers is because, for example, here at a half, it crosses twice. And the same reason for cos and so on. But graphs get their own lesson, so I don't really want to talk about graphs today. I'll talk about that in the next lesson. Okay, so let's have a look at an example. Let me show you the process. Let's pick something like minus 5 sine 2x plus 5 degrees minus 3 equals 0. And here we'll say x is possibly between 0 and 360 degrees. Does anybody know how many answers there are here? Now if you don't know, that's okay, but I wonder if anybody knows.
Four answers. Because it's like what, 2 by?
4. And we'll see the 4 answers in a moment, okay? Now I'll give you a trick. The trick here is usually the number of answers is this number multiplied by 2. Now this doesn't always work because if I make this smaller or if I make it bigger, I can get more or less answers. So for example, if this was 0 to 720, I wouldn't have 4 answers. How many would I have? 8. So if you want a rough guideline, what you do is you take this number and you double it. So what do you get? 4, and it's 4 per circle. How many circles do I have here? 1. So the answer is 4. But if it was 720, how many circles do I have? 2. So then it would be 8 answers. So what about if I had 180? Almost 2 answers. Because it's 4 per circle, so a half a circle would be 2. Okay? Now I'm not completely sure if that's true, because I guess it's possible that all our answers are in the part of the circle we're not using. So like I said, it's just a rough guide. And in fact, sometimes some of the answers are the same. So if you get 2 answers the same, then you really only have 1 answer, right? So this here, we think we can say there is a maximum of 4 answers. So this is what we do at the start. We try to work out how many answers we have to begin with. Okay? To solve this, it's a 4-step process. So, step 1 is what I call you want to get this inverse ready. What I mean is you want to rearrange it so you can get sine inverse.
Excuse me?
Yeah.
I think here you want it just like sine is minus, not when it's positive. So you have 2 answers.
Oh, you're very confident that there's only 2 answers. I like this. Confidence is good.
I'm not confident. I'm just
Oh, you're not confident. Okay, all right.
I'm asking you.
Yes, there is this thing with plus and minus. Is this what you mean?
Yeah.
Yeah. And so what is? Oh, because you see minus on the sign, it means that it should be 2, is it?
Yeah.
Yeah. But what I could do here is I could multiply this by minus 1, and then the sign becomes positive. And is it still equal to 0? If I multiply this by minus 1, I'll get positive and positive.
But when you change the 3, you get minus. And you divide it by 5, you get minus again.
How about this? How about you see the full process, and then if you're still unhappy, you can ask me then.
Okay.
Yeah. I hope you won't be unhappy at the end. I think after you see all the steps, it will be clear. Okay. So the first step is to get an inverse ready. So what I mean is, like what you're saying, we need to rearrange this. So now we have sine 2x plus 5 degrees equals 3 over minus 5. So I think I get what you're saying, that you're saying because this is negative, it's under. Is that it? So there should be 2 answers. Yeah. But because there's a 2 on the x, it shrinks the graph down, so it goes under twice. So there are 4 answers. 2 when it goes under once, and 2 when it goes under twice. This is what's happening. But after the graph lesson, I think it'll be a little clearer. Okay, so that's the first step. So that's okay, isn't it? Now the next step is to use our calculator to get the inverse here. And just before I do that, we know, for example, if I have x squared equals 9, what does x equal? Plus or minus 3. Now, just like with x squared, sine, cos and tan, they always go in pairs of 2 answers. But your calculator only gives you the first answer. So for example, if I type in root 9, what does the calculator say? 3. But we know there's a pair of answers. What's the second answer? Minus 3. Likewise, for sine, cos and tan, there are pairs of answers. So for sine, cosine, and tangent, your calculator will give you the first answer, no problem. The second answer in the pair, for sine, it is 180 minus the answer the calculator gave you, 360 minus the answer, and 180 plus the answer. this is something we will explain more in the next lesson. But for now, you can just take it as a method for finding the second answer. Not in the formula book. You'll definitely need to remember. Yes? Okay. Back to the side here. So, if I take out my calculator, I can get the first answer. Sine inverse minus 3 over 5. That is minus 36.87. Now that is only the first answer. We have a second answer here. How do I find that? It's 180 minus this answer. So that's 216.87 degrees. Actually, if you want, this is now step 2. And in this step, we need to make the extra answers. So how many answers do I have? I have 2 answers. But how many answers do I think I should have? 4. So the question is, how do we make more answers from the first pair? I wonder if anybody knows. Nope. 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 Impossible? Can't be done? What's this now? So if I have this angle here, which is 10 degrees, yes, and this angle here, which is 370 degrees, is that the same angle, the same line? Well, kind of is. I mean, if you have 10 or 370, it makes the same thing, doesn't it? So my point is, if I add 360, it makes another answer, which is a different number, but it still works. So what you're allowed to do, if you need to make more answers, you can just add 360 to the 2 answers you have. And if you need to make 2 more answers, then you add 360 again to the 2 answers you have. So if I want to make a third and a fourth answer, I just add 360 here. So 360 added to the first one, and you'll get 323.13, and 360 plus 216.87, 576.87.
And that's in another circle.
Yeah, but don't worry, we'll fix that later. But you're right, that's in another circle. But that will be fixed shortly. So we found 4 answers, but these aren't the values of x. These are the values of what? 2x plus 5. So these aren't equal to x. We're saying that 2x plus 5 is equal to these possible angles. So the next step, is to simplify to x. So for example, if I have 2x plus 5 equals an angle, what does x equal? It would be the angle minus 5 divided by 2. So if I take these 4 angles, minus 5, and divide by 2, I get the 4 x's. So I have x equals, and here are the 4 values of x. So the first one, minus 36.87 minus 5 divided by 2, and we get minus 20.94. 216.87 minus 5 divided by 2, and we get 105.94. 323.13 minus 5 divided by 2, and we get 159.07. And 576.87 minus 5 divided by 2, and we get 285.94 degrees. So that was step 3. Step 4, the last step, is fix it. So if we, well, when you're ready. Question? Where? The first one? Number 3? 159? 10x? 2x? Where's 10x?
Simplify.
Oh, simplify. 2x. Simplify 2x, not 10x. Yes. Yes. Okay, lastly is fix it. So if I go back to the question, what did I need for my x? I needed my x to be between 0 and 360. Now when I look at my 4 answers, this answer is acceptable. So is this one, but not this one. So what do we do with it?
360 minus.
You're close. Not this though, almost. We add 360. The problem with this answer is that it's too small, right? But we have learned that you can add 360 to it, and that's okay to do. So if I fix it by adding 360, my answers will be 105.94, 159.07, 285.94, and lastly, minus 20.94 plus 360, 339.1 degrees.
Why you add 360?
I thought that was your idea. Yeah. You said
I
minus though. We can minus 360 as well, but and if we need to, we can do this. But the problem is the number is negative. If we minus 360, it's still negative. We need to bring it back to positive. By the way, his point is true though. We could minus 360. For example, if one of my answers was 400, that's too big. So what would I do here? Minus 360. So, yes.
But if it's like minus 370.
Then we have to well, if it was minus 270, we could add 360 twice.
370.
Yeah, if it was minus 370, if we add 360 once, we would get minus 10, and if we add it again, we would get 350. So we could bring it back if we do it twice. Yeah. Yeah. Now, we usually give the answers to 3 significant figures, so the final answer would be 106 degrees, 159 degrees, 286 degrees, and 339 degrees. So what was the first step? First step was get an inverse ready for the inverse. Second step, make the extra answers. The third step, simplify to x, and the last step, to fix it. So I invite you to make up your own sentence to remember this order. I eat sausages on Friday. Some people have, I enjoy Superman Fridays. Uh, whatever way you need to remember it. Did you think of a dirty one? Yeah, now you see the F here gives opportunity for dirty words here. And actually so does the S. Yes, yes. Fridays. Yeah. So whatever order you want to remember, whatever way you want to remember it is fine. But what's really important is that you must do it in this order. So if you change the order, for example, if you fix it before you simplify, or if you make the extra answers at the end, it won't work. You'll get the wrong answer. The order must be this. You must inverse ready, extra answers, simplify to x, fix the answers. Okay, this is the only order that will work. Now I want to show you that this will work. So did you write the answers down? Yep. Okay, did I not pick my program? I thought I did. Was it really dirty? Was it really bad? You couldn't possibly say it, no? Okay, alright. Are you going to remember the order? Yes. Okay. No, I don't have to. Oh, here we go. Okay, what was the equation? Can you read out the equation? It was minus 5. Hang on, sine 2x degrees plus 5 degrees. I need to put it in for the program. Equals. Like this? Okay. So, what was my first answer? Oh, sorry. I don't want it equals 0. I want to see, do I get 0 if I put my answers in? So, what was my first answer? What was my first answer? Okay, now it won't be exactly 0, but it should be close to 0. No, not this. Approximate. It's pretty close to 0, and we have to round it off. What was the second answer? 159? Nope. Let me try that again. Oh, come on. 159, simplify and approximate. Again, nearly 0. Third one? 286, simplify, approximate. Again, nearly 0. And then the last one was 339. And again, nearly 0. Okay? The reason it's not exactly 0 is because we have to round it off. Yep. So it's a long question, but the good thing is that they all follow the same process of IESF. So there's just one other type to do. Can I close this screen? You can see it's all equal to 0 nearly. Okay, so let's have a look at another type. So that was 1A. So let me do maybe 2C possibly. Yeah, something like this. Okay, have a look at this one. 49 sine squared 3x plus pi over 36 plus 70 cos 3x plus pi over 36 minus 74 equals 0. Now, just before we start that, I'm going to give you a result which you might find useful and you might remember from middle school. So I'll go back to this in 1 second. What's wrong? Okay. X, y, and z. So you know from Pythagoras, x squared plus y squared equals z squared. And let's call this A. What's sine A? X over z. And what's cos A? Y over z. So that means that x equals z cos A, and y equals, sorry, what the heck? Sine A, and then y equals z cos A. If I put those two results back in here, I'll get z squared sine squared A plus z squared cos squared A equals z squared. Now what can I do with the z squared?
Divide.
Cancel, yeah. Divide them. So I get sine squared A plus cos squared A equals 1. Now this is a very useful result because it lets you change between the sine squared and the cos squared. So for example, what would sine squared A equal? 1 minus cos squared A. And what would cos squared A equal? 1 minus sine squared A. So this rule, it's in the formula book. You might remember it. If you don't, I'm telling you now. Sine squared plus cos squared is always equal to 1. As long as the angle is the same. So you don't need to write all of this down, but if you forgot it, at least write down sine squared A plus cos squared A equals 1. Yep. Now, you'll need to use that for this question, because you'll notice one problem with it. You have a cos and you have a sine squared. So what should I change? I should change the sine or cos. Which one should I change? Change the sine. I can't change the cos because it's not a square. I can only change the sine. So sine squared becomes 1 minus cos squared. So this becomes 49, 1 minus cos squared, 3x plus pi over 36, plus 70 cos 3x plus pi over 36 minus 74 equals 0. Oh, I forgot to say about the x at the start. It's between 0 and 2 pi. Okay, we'll simplify this. If I take everything to the right, I'll get 49 cos squared 3x plus pi over 36 minus 70 cos 3x plus pi over 36. 74 minus 49 is 25, yes it is. Plus 25 equals 0. Can you see why I expanded? Look, I multiplied in the 49 and I took the 49 and the 74 to the right. It becomes 25. I took this to the right, it becomes minus. And I took this minus cos to the right and it becomes plus. I'm just cleaning, that's all. I expand and move everything to the right. Make it simpler. What type of equation does this look like? It looks like a quadratic. It's like 49 a thingy squared minus 70 times that same thing plus 25 equals 0. With the help of my calculator, I know there are factors here. 7 thingy minus 5, and the other factor is 7c minus 5 equals 0. Now I'm only writing C for short, but what does C stand for? What do you think I mean when I say C? Yeah, I mean the cos 3x plus pi over 36. This question is nice because both answers are the same, so it's less work to do. So here you have 7 cos minus 5 equals 0, or here you have 7 cos minus 5 equals 0. But wait a second, this is the same. So we just need to do this one. And in fact, sometimes this one here is impossible. Like for example, if I got cos minus 2 equals 0, that has no answers. Does anybody know why? Type in cos inverse 2 and see what happens. Error, isn't it? You can only do this if cos is a number between minus 1 and 1. So here we have only one answer. One of the two. Now it's not c, it's cos. It's cos 3x plus pi over 36 equals 5 over 7. Does this type of problem seem familiar? Yes, it's the first example I did for you, the same type. So what's the first step? We have it ready, inverse ready. Second step, make the answers, extra answers. How many answers do you think we should have? 6 answers. And what mode should our calculator be in? Radians. Why radians? Well, I don't have the degree symbol. There's no degree symbol on the number. And also because at the start, sorry, I'll make it clearer. I said x is between 0 and 2 pi. So it's radians, not degrees. Yeah? Okay, so let's see what my first answer is. Cos inverse 5 over 7. So my first answer is 0.7752. How do I get my second answer for cos? Nope. Yeah, now if it's radians, it's not 360. 2 pi. So 2 pi minus my first answer, and I'll get 5.508 as my second answer. Bad news though, we still need to continue. How many answers should I have? I should have 6. So this is only 1, 2, 3, 4, 5, 6. Tony, can you give me number 3? And Nina, can you give me number 4? And then 5 and 6, please. So just be clear. You add 2 pi to make 3, and you add 2 pi to make 4. But you guys, you will have to add 2 pi twice to make 5, and here you would have to add 2 pi twice to make 6. So you need to add 2 pi and 2 pi. Okay, Tony, do you have answer number 3?
$7.0503.
7.05. We'll do 058. Okay, and Nina? Oh, so everybody's so slow. Huh?
It's a radian of
Radian.
13.341.
What is it? 13.341,
341.
342. Are you sure? What did you get?
The same.
Oh no! I can't trust you to do anything. 5.508 plus 2 pi.
Oh, okay. I just
11.791. And you got
13.341.
13.341. And lastly?
I got 18.074.
074. Now is this for x? No. What is this for? 3x plus pi over 36. So if I want the x, it would equal the angle minus, if this is equal to the angle minus
Pi over
36
over 3.
all over 3. Okay. So let's try this again. Yes?
This equation has an x. Why you divide by 3?
Ah, yes, I took the pi over 36 to the right of the word angle, and then divide everything by 3. Yeah. Wait, you don't know what I want you to do. So, what I want you to do is get the x for the first one by using my formula. Then you can do the second, third, fourth, fifth, and then sixth. You know what I mean? You sure? You look terrified. You know?
Oh, excuse me?
Yes.
How you get the 5 answers? You
To get answer 3 and 4, I added 2 pi to answers 1 and 2. To get answers 5 and 6, I added 2 pi to answers 3 and 4.
how is that? You said like you get for the cosine 360 which is 2 pi minus.
Yeah, that's to make the second answer.
Okay.
That table I gave you is to make the second answer only. Only the second answer.
How about the rest?
By adding 2 pi. And it's always adding 2 pi. You have this one. Okay, hold that for a second. Okay, Tony. What did you get as the first x? X equals 0.229.
9.
Okay. Next.
1.804.
Next. 2.323. Next.
The fourth answer is 8.90.
Okay. Next.
And
You don't have it? Yep.
I'll do the fourth.
Yes. Okay. So I'll leave a little bit of a space. What's the fifth? No, that's 1, 2. You're doing the fifth answer.
Yeah.
Yeah. And the sixth, the last answer?
5.996.
5.996. So nearly 6 then. Say again? Okay. Okay? These are our 6 answers. We need our answer, listen, we need our answer to be between 0 and 2 pi. What's 2 pi as a decimal? 6.2830. So are all of these answers between 0 and 6.2 roughly? So do we need to fix any of the answers? No, so these are the 6 answers. Now let me check that in the program, so can you just write those 6 answers down?
Excuse me?
Yeah.
For the third answer I get 34.6.
No, I think these answers, they all should be kind of small. So you might double check the third one. You said you got
I
third.
get the second one 5.5.
Are you in radian mode?
Yes.
Are you sure?
Yes.
You gonna make me come down and check? Yeah? No, that's okay, I believe you. So which answer are you saying is wrong, do you think?
I get the third one.
The third one up the top?
Yeah.
Not 7?
I multiply 5 by 2 pi.
No, add.
Okay.
Yeah, that fixes everything, yes. Okay, do you have these 6 answers? So these are the 6 answers here. Yeah? Okay, so let me go back to the computer program and let's see if they do make 0. Okay, so let me just clear all of this. Okay, so we have, what's the equation? Can you read the equation to me? 49 sine squared. I'll fix that in a second. 3x plus pi over 36. But this is squared. Okay, and next? 70? Cos 3x plus pi over 36 minus 74. Okay, what was my first answer? 0.229? Really close to 0. 10 to the minus 5 means 0.00002. So this is good. Next answer? 1.80. Again, nearly zero. So let's just jump to the last answer. What was the last answer? What was it? 18? No.
5.9.
5 point.
996.
So about 6.
Yeah.
Again, also nearly zero. So if I was to draw this graph, if I make y equals here, how many roots should it have between 0 and 2 pi? It should have 6 roots. So if we were to look at the graph, it should be something that crosses the axis 6 times. Now we'll have to zoom here a bit. Oops. And let me just center here. Whoops, too far. Okay, so we don't really care about the bit to the left here. So 2 pi is about to here. So you can see that it crosses 1, 2, 3, 4, 5, 6. But of course, like I said, if you continue, you get more and more answers. So for example, between 0 and 4 pi, how many answers should there be?
12.
12 answers.
This is only 2 pi, right?
This is only 2 pi, so there's 6 answers.
But
Yes?
is it only one circle, yeah?
Yeah. 6 answers in it. Yeah.
But in the graph it kind of only shows 2.
Yeah, but that's cosine, a plain simple cosine, not a cosine squared 3x, you know. And we'll talk about the graphs in the next lesson.
That's a little bit confusing.
Oh yes, oh no, more than a little bit, this is very confusing, for sure. Okay. Usually what happens in the exam is they like to ask this is a section A and this is a section B.
Do they ask for graphs or not?
And they do ask for graphs too. That is next time. Yeah.
No, I don't mean like a simple graph.
Oh yeah. Yeah. You worry about that next time. Yeah. Maybe not like this, but difficult graphs. Okay. In A, I want you to do a sine, cos, and tan. So that would be something like DEF would be a sine, a cos, and a tan. And then in number 2,
A and B.
okay. It's like what I did in number 2, okay. And then you can try number 3 as well. The only difference with number 3 is I don't put any limit on what the x could be. Okay, got that? So number 1, DEF, number 2, K, and number 3.
Oh.
Our next class is Thursday?
Tomorrow morning.
Tomorrow.
Oh, tomorrow morning, yes. The 9 o'clock class, which people are having trouble with. So, look, I'm going to tell you this now. Listen, actually this is very important for you. I'm starting to not like people coming in at 9:15. So if you are too late for the class, I'm just not going to let you in. Okay? So I don't want people coming in at 9:15 and 9:20. So if you're going to be this late, don't bother coming because I won't let you in. Okay? So I understand, if you come in at 9 o'clock or 9:05 or whatever, I understand, but 9:15, 9:20, becoming too late, okay?
9:14.
9:14 will just make me really, really angry, but I might let you in. But if my clock is 1 minute fast, I won't let you in. So you're playing with fire. So my advice would be to come at 9.
You might
Plus or minus a few minutes.
That would
just
be
get
ideal.
equalized.
Yeah. Huh? Okay, alright. See you tomorrow at 9-ish. Yes?